That we talked about two basic kinds of materials that prevent the movement of heat: mass-type insulation and reflective insulation. What we're going to talk about now is reflective insulation. In the last two segments, we've looked at insulation maintenance techniques with several kinds of mass-type insulation. Calcium silicate, fiberglass, cellular rubber, and plastic foam are all mass-type insulation. They contain dead air space to prevent heat losses from conduction and convection. Some of these kinds of mass-type insulation are used for high temperatures, and some can only be used for low temperatures. Calcium silicate is high-temperature insulation. It's good up to 1,000 degrees Fahrenheit or 540 Celsius. Fiberglass insulation can be used as high-temperature insulation up to around 400 degrees Fahrenheit, 200 degrees Celsius. Or, with the addition of a vapor barrier, fiberglass can be used as low-temperature insulation. Cellular rubber and plastic foam are both used exclusively for low temperatures. If they're used for high temperatures, the insulation will melt. Reflective insulation is different. It's good for all temperature ranges, for low temperatures and high temperatures, right up to the highest temperatures found in the plant. Reflective insulation works by bouncing radiant heat back to its source. Heat can't get through because it's reflected back from where it came. The insulation is made of shiny metal, often stainless steel, or sometimes aluminum. On piping systems, the insulation can be used in several different ways. Some kinds of reflective pipe insulation use many layers of thin foil to keep heat in. Each layer reflects some of the heat, so very little escapes to the outside. Other kinds of reflective insulation are used along with mass-type. The mass-type insulation is sandwiched between sheets of metal, providing a dead air space for additional insulation value. In a minute, we'll be looking at several different kinds of reflective insulation and talking about how these insulation systems are maintained. But first, let's talk about where and why reflective insulation is used. The first place you might find reflective insulation is on piping systems that operate at very high temperatures. When temperatures reach a certain point, it's just not practical to use mass-type insulation. It fails too quickly. You're also likely to find reflective insulation used in any plant area that has to be kept very clean. In this case, reflective insulation is used because it's clean. It doesn't release dust or fibers that can get into the air. Some chemical processing plants have these kinds of clean areas. Also, in certain areas of nuclear power plants, reflective insulation is required because it can be decontaminated easily. In these clean areas, your most common insulation maintenance task will be removing the insulation and replacing it during routine maintenance of the system. So, with that in mind, let's take a look at some of the reflective insulation materials you may be working with. Here's an example of many layers of metal foil being used to prevent heat losses. The space between the layers adds insulation value to the piece. Dead air helps keep the heat in. This piece uses mass-type insulation along with reflective foil and sheet metal. The mass-type insulation is sealed between layers of foil, so dusts and fibers can't escape into the clean area. Pieces for elbows, corners, and special fittings are usually fabricated to fit a particular system by the manufacturer. Each of these special pieces is designed specifically for one installation. There may be only one place where the piece will fit correctly. When the insulation system must be disassembled for maintenance, each piece should be carefully marked so it goes back in the right place. The pieces should be numbered in order, and each edge marked to show where it connects to the next section. The sections are held together with spring clips like this one. To remove a section, unclip the latch, and the piece opens up for removal. Each piece has a flange that slips over the end of the next piece in line. When the insulation goes back on, sections are latched around the pipe one at a time, and the flanges lap over for effective insulating. Be careful not to pinch your fingers when sliding the insulation together. Watch yourself on sharp corners, too. Many of the specially made pieces may be roughly finished. Jagged edges and rough corners make gloves a must when working with reflective insulation. You should always watch out for yourself, but try to avoid damaging the insulation, too. Since each piece will be used over and over again, removed and replaced many times, it's especially important to keep the insulation in good shape. Even though it's made of metal, it's easy to damage this kind of insulation. If the thin metal foil on this piece is torn or cut, the mass-type insulation inside will be exposed, and some may escape, making the entire piece unusable in a clean environment. Reflective insulation is very specialized equipment. Often each piece is made especially for one job. Aside from the necessary insulation value, it has two important characteristics. One, it's clean. No dusts or fibers can escape into the area. And two, it's easily removed and reinstalled for routine maintenance. When you work with reflective insulation, you'll be given detailed instructions on how to handle the job. The important thing is to prevent damaging yourself and the insulation. Wear gloves and handle the insulation carefully. It's expensive stuff, and if a piece is damaged, it may take a long time to get a replacement piece fabricated. By now, we've looked at all the most common kinds of insulation you're likely to be working with. We've seen how they work, where and why they're used, and we've discussed the maintenance techniques you'll need when working with each kind. In a few minutes, we'll be talking about some tips you can use to make working with insulation safer and easier. But until then, take a short break.